modeling with linear equations. We were solving word problems by making a little table of information and organizing everything and writing an equation to solve the problem. So we're going to do a little bit more of that today. But this time, the equation that we're going to end up with won't always be a linear equation. Okay, so sometimes it'll be quadratic, sometimes it'll have fractions in it. Okay, so more story opportunities. They may involve quadratic equations as opposed to linear that we saw last class. And there are a few standard applications that end up being quadratics. So falling body problems, which we saw a little bit of 2 classes ago. Area problems and profit problems. So we'll do a couple examples of these, and then like last class, I'm going to have you do some in your groups, and I'll come around and help you. So the first sort of standard college algebra modeling problem that involves quadratics is a falling body problem. And it says if a ball is thrown upwards from an initial height of h0 feet, so that's the height from which you initially throw it, and it has an initial velocity of v0, that's the speed that you throw it with, then its height at any given time is given by this formula. Okay. Before we start to answer the question, this formula looks a little bit different than the one I gave you a few classes ago. What's different about it? Anybody remember what that one was? It didn't have velocity in it because that one was when we were just dropping something. We weren't throwing it up. So its initial velocity, if you just hold something and drop it, what's its initial speed? 0. So the v0 is a 0, and that whole term drops out when you're just dropping something. All right, so we're dropping a penny from the top of the Washington Monument, 555.5 feet, and we're just dropping it, not throwing it. How long does it take to fall to the ground? So we're going to write down our equation. I'm going to fill in the things I know. So h, I don't know, negative 16t squared. v0 in this case, because I'm just dropping the penny, is 0. So this would be plus 0 times t plus h0, which is the initial height I'm dropping it from, which is 555.5. Right, we do know h because they want to know how long it takes to fall to the ground. So when the penny hits the ground, what is h? 0. Okay. And then you can use your favorite method of solving a quadratic to do this. You could do the quadratic formula, you could extract roots, you could try to make it factor. Do your favorite thing. What do you want to do? So we could move the 16t squared over, add it to both sides, and we get 555.5. And then what should I do? I could square root because it's easy to square root 16, but what could I do first that would make this a little bit easier? Divide by 16. You want to get the t as much by itself as you can before you square root. So I'm going to divide by 16. So I get t squared equals 34.7. So then t, say it again, 5.9 seconds. So once I got to the t squared, I square root both sides. And I don't write plus or minus, which I normally do because can't have negative time. I mean, you can have negative time, but it just means what happens before I dropped the penny, because time 0 is when I let go of the penny. And this model just doesn't apply for negative time. The penny was probably like in my pocket, and this model isn't going to tell me where the penny was. Okay, so let's say we're at the top of the main building at GCC, and This time, instead of dropping a ball from the top, we are going to throw it straight up. Throw it straight up in the air with an initial velocity of 40 feet per second. And we want to find out when the ball reaches a height of 24 feet. So I'm going to write down my general equation. Okay, so the question is when, right? So I'm going to be solving for t, because t is time, the answer to a when question. So everything else I need to be able to replace with a number. So what should I replace h with? 24, great. And v naught will be replaced with 40 and h naught with a 96. Now we solve this with any method we want, any quadratic. So what should we do? Okay. Okay, so you want to put the 16t squared on the left and the 24 on the right. So well, then what would you do? Yeah. Right? Okay, now what should we do? So what did you say? Quadratic formula? Quadratic formula? So what does the equation have to look like before we're allowed to use the quadratic formula? It has to be equal to 0. So I'm going to actually move everything over to one side. So I'm going to subtract these guys and move them over to the left. So I have 16t squared minus 40t minus 72 equals 0. Now I can use the quadratic formula. So in this case, a will be 16, b will be negative 40, and c will be negative 72. And x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's see what we get. We're going to have negative b, or the opposite of b. B is negative 40, so the opposite of b would be 40. B squared, well, negative 40 squared would be 1600 minus 4 times a, which is 16, times c, which is negative 72, all over 2 times 16. And I got to open a calculator to do this. All right, so let's see. I've got 4 times 16 times 72 is 4,608. And it is positive because it's a negative 4, a positive 16, and a negative 72. So this is going to be 40 plus or minus the square root of 16 plus 4,608 all over 32. Sorry, 1,600. So I add 1,600 to this, and I get 6,208. 40 plus or minus the square root of 6,208 over 32. And 6,208, if I square root it, I get 78.8. My A is not negative 16. It depends on which side I put everything on the equation, and I moved everything so that the 16t squared would be positive. So yours might be negative, yeah, if you did it a different way. It's okay. So notice that once I get rid of the square root, I have to round the decimal, right? And that decimal actually keeps going on after that. It goes on forever without any repeating or stopping. So I have to round it. So once I round something, I use these squiggly equal signs to mean approximately equal to. So if WebAssign asks for an exact answer, you would just type in this guy, right? But in a real life problem, like a falling body problem, when they ask you how long, you would give a decimal approximation, because if I said 40 plus the square root of 6,208 over 32 seconds, nobody would know what that meant, right? They'd be like, tell me approximately how long that is. So we give the approximate answer in real world situations. All right, so let's see, plus or minus, we'll do the plus first. 40 plus 78.8 over 32 is 3.7125 to 5 seconds. And if I do the minus, I'm going to end up with a negative, because 40 minus 78 is going to be a negative number over 32 is still negative. And since I'm dealing with time, I just only want to give the positive answer. So about 3.7 seconds for the ball that we throw upwards to get down to 24 feet. How's that? All right. Okay, so here's another classic quadratic problem for area. We have a picture frame that is 2 inches wide. So the thickness of the frame all the way around is 2 inches. And the picture inside the frame is 4 inches longer than it is wide. The area of the picture, just the inside picture, is 320 inches. We want to find the outside dimensions of the picture frame. So, find the outside dimensions of the picture frame. That's the question, right? So let's label those things. Okay, we'll let the answer to the question be the variables. So let's have L be the length of the frame and W be the width of the frame. So we'll have L and W. Okay, so now we're going to try to draw into the picture all this other given information. So I know that it's 2 inches around. So I know that this distance is 2 inches. And I know that this distance is 2 inches. Okay. In all of these corners, 2 inches. So if this outer dimension is W, I would like to know what this length is that I highlighted in red there. Yeah, W minus 4, because it's W minus 2 inches to the edge and 2 inches to the edge on the other end. So this guy is W minus 4. And if this whole length across the top is L, what is this length across the top of the picture itself? Say it. L minus 4. Taking off 2 inches on the left and 2 inches on the right of the actual picture frame. Okay. So now What do I know about the area of that picture frame, of the picture itself? And how do you calculate area? Length times width. And the length and width of my picture are L minus 4 and W minus 4. So I have L minus 4 times W minus 4 equals 320. So there's one equation, but I have two unknowns, which means I need another equation, right? How could I write another equation? The last bit of information that I haven't used is that the picture inside the frame is 4 inches longer than it is wide. 4 inches longer than its width. So let's do this. If I have L minus 4, that's its length, and its width is W minus 4, which of these is longer than the other? L minus 4 is the longer dimension, right? We labeled it that way. L minus 4 is longer. How much longer is it? 4 inches, not 4 times. 4 inches longer. So to make them equal, I have to add 4 inches to the other one. So if I want to put an equal sign here, right now they're unequal, right? This one, L minus 4 is longer, so they're like this. So to bring them back to equal, I have to add 4 to the other side. So I have L minus 4 equals W. So that's my other equation. And then that's handy. I could just replace the L minus 4 in this equation with a W. So I have W times W minus 4 equals 320. L minus 4 is W. So I replaced this L minus 4 with a W. Finally, I have a quadratic equation I can solve. So W squared minus 4W minus 320 equals 0. How do you solve that? Does it factor? You could use factoring if it factors. I don't know. What if factoring doesn't work? What would I do? Quadratic formula. Okay, so I have W is negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Okay, so 4 times 320 is 1280, and it should be positive because I have a negative 4, positive 1, negative 320. So I have 1280, add 16 to it. Take the square root of that, and I get 36. So I have 4 plus or minus 36 over 2. So 4 plus 36 is 40, over 2 is 20. And 4 minus 36 would be negative 32, over 2 is negative 16. Now, am I going to keep both of these? Why not? Right. W is representing a length. No such thing as negative distance. So only the 20. So my outside width is 20, and the length would be 16, L minus 4. W plus 4. Yeah, right. W plus 4. So W is 20, 20 by 16 would be the outer dimensions. -16 is not from the -16, right? It's from 20 minus 4. Came from this equation right here. If L minus 4 is W, right? And I know W, then L is, 24, sorry. Yeah. 20 by 24. There are different approaches to this problem too. So don't feel like there's only one way that you would get this answer. So another thing that would be really common, you could let the inner dimensions be L and W, right? And then the outer dimensions would be W plus 4 and L plus 4. So that's another way that you could set it up. Any questions on that one? Okay, so I think one more. We have a rate, time, and distance problem. So Karen drove from Tortula to Cactus, which is 250 miles. And then she went to Cactus to Dry Junction, which is 360 miles, and she went 10 miles per hour faster on this leg of her trip. And the total trip took 11 hours. What was her speed from Tortula to Cactus? So this is very similar to the ones we did last time. So this is definitely an RT equals D problem. And there are 2 legs to the trip plus a total trip. So let's see, we've got Tortula to Cactus, Cactus to Dry Junction, total. So we organize our work into a table. So what is the question in this problem? Okay, so her speed from Tortula to Cactus will be our variable. So we'll let that be X. Put Tortula to Cactus, her rate was X. We don't know. So once we finish solving, we get X equals, that will answer the question. All right, and then let's fill in the other stuff we know. It said Tortula to Cactus is 250 miles. And then she went 10 miles per hour faster from Cactus to Dry Junction. X plus 10, great. And says that that was 360 miles. The total trip took 11 hours. Now, speed isn't additive, right? If you go 30 miles per hour and then 40 miles per hour, you can't say I went 70 miles per hour over the whole trip, right? So we can't add the X and the X plus 10. So I'm just going to leave that box blank and hope I don't need it. All right, so if rate times time equals distance, and I know something about rate and I know something about distance, what is time? If I solve this equation for t, what do I get? Distance divided by rate. Yeah. So I can put in those 2 remaining boxes, I can put distance divided by rate. I can put 250 over x and 360 over x plus 10. And actually, I guess I know the total distance. That's not too bad. 610 miles. All right. If you drive, let's just say for a second, it took her 2 hours to drive from Tortula to Cactus and 3 hours to go from Cactus to Dry Junction. What was her total traveling time? 5 hours. How'd you get that? You added the 2 times, right? So if I add the time driving Tortula to Cactus to the time driving Cactus to Dry Junction, we should get the total time of 11 hours. So there's my equation. My two times add together to make the total. So I have 250 over x plus 360 over x plus 10 equals 11. Now, that kind of equation we learned how to solve 2 classes ago. So I want you to try it in your groups. See if you can solve this equation. We'll go over it. So let's go through, remind ourselves how to do this. So I first showed you a way to eliminate the denominators one at a time. Again, some people like to do it all at once, which is fine. But I'm going to do it one at a time so you can get see what I'm doing. So I look at this equation and I see that it has fractions, and I think this equation would be so much nicer if it just didn't have fractions, right? So I'm going to try to get rid of them. I'm going to try to get rid of the denominators. So I'm going to use the fact that if I were to multiply 250 over x by x, the top and the bottom would cancel. The x's would just cancel. 250 divided by x times x would just give me 250. So I would love to multiply that fraction by x, and luckily I'm allowed to multiply by anything I want as long as I do it to both sides of the equation. So I'm going to multiply both sides by x. And when I do x times 250 over x, I get 250. And then I also have to distribute that x, multiply it to the other fraction, and that's like an x over 1. And when you multiply two fractions, you multiply the tops and you multiply the bottoms. So we have x times 360, which is 360x, divided by 1 times x plus 10, which is x plus 10. And on the right, I have 11x. So I've gotten rid of one of my fractions. Now I'm going to work on the other one. I'm going to try to get rid of the x plus 10. It's in a denominator, so to get rid of it, I'll just multiply by it. But the rule is if you do it to one side, you have to do it to the other. So multiply both sides of this equation by x plus 10. So then I have to distribute the x plus 10 to both terms on the left side of the equation. So I do x plus 10 times 250, which is 250x plus 2500. And then you do x plus 10 times the next times the fraction, and I have an x plus 10 on top, x plus 10 on the bottom. They cancel, and I have plus 360x. And that would equal 11x squared plus 110x when I distribute my 11x. All right, so now I combine all my terms onto one side. This is a quadratic, so I'm going to have 11x squared. I have 110x here. Let me get my calculator so I don't lose track. Okay, so I have 250x and 360x. Add them together, and I get 610, but then I'm going to subtract that from both sides of the equation. So I have 110 minus 610, negative 500. So I have 11x squared minus 500x, and then also subtract the 2500 minus 2500 equals 0. So everybody see what I did? I moved everything to the right side, but then you can put the 0 on either side. It equals 0, whether I put equals 0 or equals 0 over here, right? It all equals 0. All right, so we can either try to factor it. Don't want to do that. Or I can use the quadratic formula. So I would have x equals negative b plus or minus the square root of b squared, 500 squared, what's that, 25,000, 250,000? 250,000 minus 4 times A times C all over 2 times A. So I have -4, +11, -2,500. When I multiply those all together, I'm going to get a plus. So 4 times 11 times 2,500, 110,000. So 250,000 plus 110,000 is 360,000. Square root it. 600. So I have 500 plus or minus 600 all over 22. So 500 plus 600, that's 1,100 divided by 22 is 50. And 500 minus 600 is negative. And what is this answer representing? Speed. So speed in miles per hour. So we don't want a negative answer. So negative something, and I don't even care what it is, because 50 is my answer. Well, that was a fun one. Okay, so again, watching me solve them isn't that helpful. So what I'm going to have you do is work through a few problems in your groups, talk to each other, get ideas from each other, and let me know if you have questions.